Good evening, all. This is Ashok Kumar. Hello, Suthar.
Oh,
Hello, good
sir,
evening, Suthar.
can you hear me?
I am audible?
Oh, yeah, yes, sir. You are audible.
Okay, should we start?
Sir, actually, the link is actually wrong. I came at right time, 7 p.m.
Link shared by that NPTEL team.
No, in the Swayam website, the link they shared a link for Google Meet. The link is actually wrong. And in my WhatsApp number, NPTEL has also shared a different link. So I joined using
No,
that
no, no.
link.
We have shared you on the yesterday night that.
No, the link which was displaying in the portal and the link in the WhatsApp messages both are different. I
I
joined in
will,
the wrong.
I will inform to them that.
Yeah, actually, I used the link from the portal, so I was waiting for 5 minutes to let someone in. So
The
I
portal link will
discovered
be right.
what, sir?
That portal link will be right.
No, actually, as I said before, the portal link I was waiting for 5 minutes, like no one has let me in. And I again checked my WhatsApp message and the link, both the link are different. So I joined by WhatsApp link.
So means that WhatsApp link is correct and that portal link will be different.
Yeah. WhatsApp has different meeting link and the portal has different meeting link.
Okay, okay. I will write to email to them.
Yeah.
Okay.
Yeah, yes, sir.
Okay. Thanks for information.
Oh, yes, sir. I
That's why
thought like
people are unable to join maybe.
Oh, yeah. So that's why I thought like whether maybe some issue from your side probably. So
No,
I
no,
thought like,
no. Actually, I am not aware about that things.
oh, okay. Uh,
Yeah. Otherwise, I will write the email to them that definitely that this is the that blunder with they have play with me.
oh, yes, sir. Actually, right now only I checked like both the link are different. So I joined in the wrong meeting. Like, and
Okay,
I
okay,
was waiting for 5 minutes. Yeah.
okay.
Hmm.
I think where is that girl?
Jabira,
Yeah.
I think she is having something in her house. So I think, yeah, she will
She will
join
not
like.
do.
Actually, when she goes to home, like she is busy, like tutoring and lot kind of stuffs like that. So I think, yeah,
What type
if
of tutor?
she like she teaches for some school childrens.
Okay.
Uh, yeah, so I think like maybe the timing maybe collided or something. Maybe
So I
she,
told her to that if he will be not, then we will change the timing.
yeah, okay, and I think like if she want, like she can also like. Yeah, I will say, sir. I actually mentioned like in previous class also you are absent. So yeah.
So she will be not like that class also that I think that.
Oh, no, sir. Like it's not like liking. Like maybe she kind of busy. And right now I messaged her and she said like she would be around at 7:30 p.m. So you can start.
I will just check that link that I will verify that.
Yeah, if you see the link, the both the link are quite different. Like
I will check in the announcement. You have to check with the announcement.
yeah, you go to the announcement tab and there is the link for April 4 today. It is XNU GRJN FGN.
April 3 that you have to join April 3.
No, sir. It is today.
I,
Oh,
I
1 minute.
this link is correct that today is April 3 link you have to you are joined
Ah,
maybe.
okay. Oh, sorry, sir. Actually, like when I go to announcement tab, I watch the new announcement.
That is for the
So,
yesterday that tomorrow announcement
ah,
that April 4.
okay. Oh, I thought like it is for today's link. So
No,
I
no, no, no,
press.
no. 2 days is in between because these two classes are continuous. So people are maybe that.
Okay. It's fault from my side. Okay. Yes,
Because
sir.
I do not know, even I have not access to inform you regarding the class that I have not accessed that.
Yeah, actually, it's my mistake. I didn't check the data. Actually, I wrong
But they
joined
have
the.
not provide me.
I just saw the new message from the announcement section, so
Yes, yes,
that's why.
yes. That's why it is for tomorrow class. They have
Yeah,
informed
yeah,
me.
yeah. Yes, like. Oh,
Okay,
hmm.
Bala. So we have start.
Yeah, yes, sir. We can start.
So okay, good evening everyone. So this is Ashok Kumar, PMR scholar, and this is for that discussions class for week 8 of sensor and actuator. So uh, maybe I will be happy to take your first doubt and then we will proceed for that some questions and discussions. So if you have any doubt, you can ask first, and I will take some question and answer and some basic parts of that photolithography, photoresist, and that SMA, small metal material alloy, that part for the fabrication of that actuator. So if you have any doubt that, or should we move?
Yes, sir. We can move.
So the first question is that I have given mention some that components, and you have to select that which is the initial component for that photolithography. So can you answer that?
Uh, Solvent and synthesizer and also base material.
Solvent and
Sensitizer.
okay.
And we also had base material.
We need we do not need a developer.
No, sir.
Uh,
No, sir. Like photoresist, like we need solvent, sensitizer,
yes,
and
we
base
need a
material.
solvent, sanitizer, and base materials.
And what are metal nanoparticles, sir, actually? Like,
These are just like that metal is like that. We take the gold like that, AU.
oh,
Okay.
okay. Mm-hmm.
Or some people are taking that PD or PT, platinum or pentanium. Okay.
Mm-hmm.
So
Mm-hmm.
these are particles are used for as a sensor material or material or that source for that.
Ah.
Okay. So what will happen? They have a like the type of the nanoparticles. They have a synthesis either
Mm-hmm.
through sputtering, ALD, hydrothermal method, soldier method. There are different method for synthesis of the nanoparticles. Okay.
Mm-hmm.
So
Okay.
what will happen like that? I have fabricated that. I have designed the sensors on silicon wafer.
Mm-hmm.
So I have made the through the electrode through the photolithography. Like this is the two electrode for electrical contact or for characterization. Like that I have
Yes.
made the gold. Okay.
Yes, sir. Yes,
What
sir.
if this is the sensing layer? Some people are deposit through that. I have previously class I have mentioned that physical deposition paper method, chemical sputtering, RF magnetic sputtering,
Mm.
MOCVD, molecular MB. There are different equipment used to deposit the sensing layer or materials for the synthesis. So
Yes.
what will happen that people will be drop cast or some they have to some decorate with these metal nanoparticle hairs. Okay,
Mm.
and
Okay.
then this will be help in the improvement of the sensing performance like that response, rise time, fall time, selectivity of the sensing sensors. These are will be help in that case also.
Okay. Okay.
Okay.
Yes, sir. Yes, sir.
So these are matter particles are mainly used for that as a sensing layer or for that improvement of the sensing sensor for that.
Oh, okay. Sensing
Developer
layer.
we use after that photoresist and photolithography transfer of the pattern for the transfer development of that pattern we have to use the developer.
Hmm. Okay.
So development all will be after that. exposure of the pattern through that shadow mask on our devices, and then we use the developer to develop that pattern on our devices.
Yes, sir. Yes, sir.
Developer will be according to that photoresist we use the developer. What type of the photoresist we use, either the positive or negative, as per we have to use the developer to develop that pattern.
Hmm.
So when we have to buy the photoresist, we have to parallelly buy the developer also for that photoresist also from the
Oh,
market.
but here only the basic components are only solvent, synthesizer, and base material. Why not developer?
Because for photoresist, we initial component photoresist will be made through the solvent, sanitizer, and a base material. Like that,
Ah.
if you like that, we have take the PMMA photoresist,
Mm-hmm.
polymethylamine material photo acrylics, like that PMMA photoresist, like that. Yeah, SU8 is the negative type photoresist, or
Okay.
PMMA photoresist we use. Okay, so how
Mm-hmm.
will this photoresist will be made? PMMA type. We use the some material. Okay, then we have to
Mm-hmm.
that material we have to, because we need a liquid type of that photoresist.
Yeah.
Because we want to drop cast and spin coat. So how it will be soluble? It will be soluble in the solvent,
Yes, sir. Yes, sir. Solvent.
and then we, after that solvent, we have to sanitize that, because we want to that this will be have some adhesive property, good adhesive.
Adhesive.
So there
Yeah.
will be some sanitizers in that. We have to add some materials to sanitize that photoresist.
Okay.
Okay.
Mm-hmm.
So, but metal nanoparticle will be not helpful because it will be for conductive. We do not want the conductive photoresist.
Yeah. Conducting node. And
And
what is base
developer
material?
we use the, after that transfer of the pattern we use the developer.
And base material, sir?
Base material, this PMM is the what is the how to photoresist will be made. Some metal SU8 is the material.
Ah. Oh, okay,
And
okay,
material
okay.
photoresist will be not like that liquid, that like that it is of some powder form.
Oh,
Okay.
base material, we mix it in
Make the some
solvent.
that powder form, they make the some solvent of that soluble, and
Ah,
then
and then sensitizer. Okay,
yeah.
okay. Yes, sir, yes, sir. Now I
Okay.
understood. Hmm. Yeah.
Pritam, are you there, Pritam? Pritam.
Yes, sir.
So, hi, how are you?
Fine, sir.
I think you are joined first time that.
Yeah, I tried earlier, but I did not join due to some technical reason.
Okay, okay. So, are you PhD student or
No, I'm completed just MSR from IIT Delhi.
MSc?
Planning MSR,
MSR mean?
Master of Science in Research. That is equivalent to MTech program.
Okay, okay. From IIT Delhi.
Yes.
Now what you doing?
I'm a staff in IIT Delhi, so I'm planning to PhD in future, maybe after 6 months or 1 year. So I'm interested in fabrication, so attending this course.
So, you take the admission in IIT Delhi itself, or you plan for some foreign university?
No, no, just in IIT Delhi because my job is in IIT Delhi.
So, you are on the job,
Yes,
on a project or some permanent?
no permanent. The deputy technical officer.
What?
Deputy technical officer.
DTO.
G.
Oh, so you are the, it is, I think that you are around 10-year experience.
Yeah,
Which department you are working?
electrical engineering.
Electrical, or that school of that applied electronics or center that?
No, no, I am in electrical engineering department.
Okay, okay, okay. So you know that people that Samvesh Das, and
Yeah, yeah. I
he,
am
he
currently
is
doing
working on
some
the
course
sensor
under
only. That.
him. Sorry, unable to.
He is working on the sensor, on the gas sensor.
Professor Das.
Yeah, Professor Samvesh Das, Professor Rajendra Singh,
Yeah, they working on devices and sensors.
Professor Ashok Ganguly is also on that chemical
Yeah,
part. That
yeah. And the other faculty also in the E department like Professor Diman Malik, Bhaskar Mitra, Madhusudhan Singh, they also working in fabrication.
they are working on gas sensor or optical or some other.
Professor Anuj Daman working on gas sensor.
Okay. So I think you have the good facility that you have the science department of that center facility also. That have you visited that?
Yeah, we have some good facilities right now.
Yeah, you have two HRM, HRTM, XPS, Raman, CVD, that XRD.
Yeah, that I have done with the under the Professor Das, Samresh Das. Currently, I'm doing one course also, fabrication course.
Okay, okay. So you are planning to do PhD under him also.
If I get time, then I will think of
Yeah, he is a good friend of my supervisor,
who is your supervisor here.
Dr. Mesh Kumar.
Oh, IT Jodhpur.
Yeah, IIT Jodhpur.
Yes. Yes.
You know
Okay.
him?
No, I don't know Professor Mahesh, but I know some of the faculty in the E department, like Professor Niladri was
So he is
PhD
working
here
on a robotics part.
in, yeah, and that the lady, I don't know, the
Sakshi,
core, Manpreet,
Amandeep Kaur.
Amandeep Kaur, the she
Yeah,
is,
she is passed out from IIT Delhi. She is working on that cadence and that CMOS and that
so
uh,
she knows me,
camera design, chip design,
image processing.
image
Yeah,
processing camera. Okay.
yes,
Okay, okay. So you are now you have to win the job and you do part time at MSR, huh?
yes, yes.
Okay, so it is completed or this May it will be completed?
No, I completed in 2 year back in 21.
2 years back. So you can plan the PhD also there part time.
Yeah, I'm thinking of, but I don't have a right now some time because I am married also. I have a kid of 8 year old, so need time for him also.
But meanwhile, you can do the your coursework and that complete part and that everything that whatever that for 1 year.
Yeah, I'm planning this. Maybe soon I get started with somebody.
Easy for you to take the part time PhD admission in IIT and
Yeah, faculty insisting me, but I'm finding time, good time for because we need dedication also. Na taking admission is not enough.
yes, yes, because you have the good facility of the instrumentation and everything characterization. It will be that helpful you to to
Yeah,
complete the PhD in the good time.
yeah. Already have some experience also na in research during MSR. My work was on devices itself in reliability with Professor Dixit.
So which devices you are working?
I worked IBM's 7 nanometer FinFET devices. I was testing some HCI degradation and radiation effects on the devices.
Okay, you have to fabricate FinFET.
No, we have not fabricated. Professor Dixit has a collaboration with IBM. He was earlier working with IBM.
So
So
they will
he
provide
has,
you devices. They will provide you devices. You just do the ion
yes,
irradiation.
they providing the wafers. So we working on that.
Okay, okay. So you just do the ion irradiation and you check that property of that, how much the
What
effect
is
of
the
the.
effects on the devices?
It is double gated, so you have to take the 4 probe station for that.
We have Professor Dixit has that facility. They have cryo facility also. So now they working on quantum also. That quantum
FinFET,
computing and all the
you have to take the double
cryo
gate. FinFET is the double gate devices.
that FinFETs
Yeah, FinFETs.
they try gate na triple gate.
Yeah,
But
some are.
you have only one pad for gates. I was working in RF devices, so they have only GSD pad sets.
Okay, okay, okay. Good, good. This is a very interesting things.
Yes.
Okay, okay. So, have you facility of that photo detector characterization? UV.
UV. I don't work. I did not work, but I can find if one of my friend or have. They have good facility for photonics devices also, but I don't know exactly right now. If you
I
need
think
any
that
specific, I can search it.
Rajendra Singh will be have like this facility. I think.
Okay, maybe.
Balaram Tag,
So
you know that he will be working on it. Yeah, the PhD
who
scholar.
PhD scholar who?
Balaram Tag.
No, I don't know because he's belong to that physics department or he.
I think Rajendra Singh in
Rajendra
the
Singh is belong to physics department.
physics department. One is Rajendra Dakas. I think that in electrical.
No, though he is also not in electric, he is also in physics.
Okay, okay, okay. Okay, okay, good, good. You have to. I think you have to do PhD and you have lot of experience about the fabrication.
Yeah, देखते हैं सर फ्यूचर में.
Okay. Thank you. Nice to talk to you.
Okay, thank you also.
So next about that, to complete the following statement in the spin coating process, the thickness of the deposit will depend on what parameter?
Like spin speed, duration, and concentration and volume, both A and B.
Both A and B.
Hmm.
Why not that spin speed RPM?
Like it also depends on concentration, na? Like volume of the like it basically decides the thickness volume also.
Yes. It they have just confused you that they have mentioned that separately that spin speed and spin durations. So when
Uh,
we have to like that, we have to coat the photoresist on any silicon wafer or glass wafers, drop cast something. So
mm-hmm.
we have to optimize the thickness of the PR, that photoresist, as per our design of the mask and intensity of the light source. We use the photolithography. In case
Mm-hmm.
of the like that, if you use the electron beam lithography, electron as a gun source, so we need around 50 nanometer or 100 nanometer thickness is sufficient to transfer the pattern on that our device. But if in case of that we use the UV or X-ray case, we need around that 300 nanometer or 400 nanometer thickness of the PR, because it will be otherwise that less thickness will be not able to expose that pattern on that devices. So thickness will be depend upon how much duration we have to do the spin coat, what is the RPM that we either we have to say 1000 RPM, 2000, 3000 RPM, and the concentration and volume of the dispersed solution. If it is more diluted or in the liquid dispersed form, it will be easily circulate on the surface, or it will be thick or very thinner. In that case, thicker in that case, it will difficult to uniformity circulate on that vapors. So we have to take care of that about that photoresist solution also during that deposit spin coat also that.
Yes, sir.
So to fabricate SU8 pillars on chrome oil layer, what is the sequence of the process to be followed?
Spin coat, uh, spin coat, soft bake, UV exposure, hard bake, then photoresist development and annealing,
So spin coat, soft bake, hard bake, and then
UV exposure, hard bake, PR development and annealing.
okay. So we have to do first hard bake and then PR development.
Yeah, like as I say, like SU8 has soft bake, hard bake, then only we expose the UV and then photoresist, right?
So why we need after the development we have to do the annealing in at what temperatures?
Like annealing,
Yeah. Why we required that things in the
like I think I asked the same question and you have mentioned like depending upon the devices we fabricate, like we need to change the process for the SU8. So
no hard
maybe
bake is a okay thing. We have to maybe sometime people are doing the UV exposure. After that hard bake means UV exposure will be after the UV exposure on the photoresist. Maybe it will be brittle or some thing will be happen with the PR. So we have to transfer the pattern. We have to do hard bake before the PR development. Some people are doing without the hard bake developer. They use the. But what
Mm-hmm.
happens with the N-link? That why do after at last when after the development of the devices we have to do the N-link?
I'm not sure with the answer, sir.
Actually,
So.
like that, this PR development is also solution. The development will end up in the solution form. So,
Mm-hmm. Yeah.
or after the development, we what will be happen to what will the residues will be remain on the surface of that our devices. So we
Ah.
have to remove that residues. So we have to do L-ning at around 200 degrees Celsius or 400 degrees Celsius. Okay. Some water
Oh, okay.
molecules will be remain, some stress will be there in the devices, some PR,
Hmm.
some particles of the PR maybe will be in the remain on our devices. So when we
Ah.
have to check in the microscope after the develop of the device, we check that our something impurity will be there on our devices.
Oh,
So
yes, sir. Yes.
when we have to put the our devices on a developer, we have to also like that optimize the time of that it like that. Some device will be developed in the 10 second, 30 second. It's depend upon the materials that electrode material we have used, either chrome, gold, silver, or whatever the aluminum we use. So in case of the positive photoresist, we first develop the electrode or metal on the surface of that devices. In case of the negative photoresist, maybe we have to deposit after that developing of the devices. So in the both the cases, we have to do the earning because we have to need the addition of our devices also that on the surface. Either it will in the after the develop it may be rinse or maybe remove in that case also that. So need to remove that water molecules or some residue or make the good addition of the devices on our surface of that silicon or materials. We need to do the handling.
Oh, yes, sir. Yes, sir.
Okay.
Yeah.
So see that this is the step we have to follow during that SU8 pillars. Like that, we have to in the silicon wafer we have already deposit chrome, gold chrome, that 500 angstrom, 500 angstrom and 200 angstrom. Then on that deposit of the metal, then we have to deposit SU8 on top layer around 1.8 micrometer of the thickness, and then we have taken out that EU metal wires on that above that photoresist of 1 micrometer to check that to make as a register of the gold contact for resistance. And in the bottom, to take the bottom electrode, we for gate source we have to deposit SU8 at the bottom layers, and these are all the steps we have to make to the like that we have to fabricate either CMOS or transistor. In that case, we follow this step during SU8 photoresist. Hi, Jabira. Hello. Jabira, are you there?
Hello,
Hello.
sir. Good evening, sir.
Good evening, Jabira. How are you?
Sir, doing good, sir. How about you, sir?
I am also fine.
It
I
was a
missed you last
hectic
class.
day, sir. Yes, sir. It was a
I
hectic day
missed
last
you a lot
week.
of the last class.
Yes, sir. I missed it, sir. I couldn't even attend, sir.
Why? What happened? Are you feeling not well?
No, sir. I was having a hectic day, sir. On that day.
Okay, okay. So I have suggested you we can reschedule the class also according to you that.
Yes, sir. But Sudarshan from my class, he has attended, sir. So it was
Yes. Yes.
helpful for me.
Okay, okay.
He told me whatever you tell him.
No, no, we can reschedule because if you are difficult in the week class, then we can go to weekend also that. Vietnam, if
No,
you
sir,
have
it
any
is
problem, we go to
really
week.
convenient for us to taking
What?
class on Mondays.
What happened?
So it is completely convenient for us, sir, about
Vietnam,
having class on Monday itself.
okay, Vietnam, are you fine with that class?
Yes, yes, sir.
Okay, okay. So Jabir, have you any doubt?
No, sir, it's going smoothly.
I have included that your doubt in the last class also, that first things are. But
Regarding,
but
sir,
that whatever the last class you have asked me doubt, I have included in the week 7 class that also, but I am waiting for you in the last minute also. But
Actually,
okay, you go through that video that if you have any doubt, and then you can ask me to that.
sure, sir,
You
sure, sir.
I have given you my WhatsApp number. You can ping me that also. That
Sure, sir.
okay. So next question is, what is the purpose of the performing dehydration bake? And what do you mean by the dehydration bake?
Sir, it is removing the moisture after the wafer cleaning process.
So moisture, how moisture will become on the vapor during that? Because we have to work on the clean
Baking,
room.
sir.
We use the fume wood. Everything we have to take care that. So what do you mean by the dehydration bake? Meaning of that dehydration? It is your answer is correct. So what this word will be that say to you that how from reading this word how can you that understand that dehydration may be?
Like we sometimes clean the wafer using also like bubble jet process. So sometimes the H2O molecules can residue in the wafer. So at the time we use the dehydration bake to remove those
Because
moisture
it may
content.
cause some defaults in the manufacturing
Actually,
materials.
actually, what will we have to do when we have to develop our devices on that silicon substrate or glass substrate? So after developing, we have to rinse our devices on the DI water. Okay, DI means deionized water. It is we have to remove all the metal particles and other impurity from waters through the filter, and it is safe for our devices. It will not introduce any impurity in our devices. So DI is in the water form. So either we have this, if you have to keep in the open atmosphere when the vapor will be evaporate, it will be maybe left some residue on the surface of our devices. Some waters printed will be when we would see in the microscope. You see that some design will be developed on our devices after the evaporation of the waters. So we have to bake in the high temperature, around 200 degree and 300 degree Celsius. So it will be evaporate all the water molecules, and it will be not left any residue on the surface of our devices. But in the some cases it will be not happen. So like that, dehydration bake are the main implies remove waters from the substrate surface by baking at temperature of the 200 degrees Celsius to 400 degrees Celsius, usually for 30 to 60 minutes. The substrate is then allowed to cool briefly in the dry environment and coated as soon as possible. Means when we have to dry that, like that, when we have to clean our silicon vapor, or after that W our device, we have to do the dehydration bake. So the dry environment means we will have to keep our devices in the vacuum form. So either we have the vacuum chamber or some that what that said name that you have to use the desiccators. So in the desiccator you have to keep your devices, and then you have to create the vacuum in the your desiccator through the rotary pump or vacuum pump that available in the market. So when you have to work in the clean room, that equipment will be easily available for you to access that things. So it is important to know that water will be resolved on the substrate surface if left in the humid non-dry environment. So after a dehydration bake, if you keep your device in the open atmosphere, so maybe some water molecules will be absorbed again in the dead case. So you have to keep in the dry environment or devices. So either it will be change your property of the devices also that. So a dehydration bake is also effective in volatilizing organic contamination. So whatever the last to last class we have to discussion about that plasma etching, and that we have to do in the oxygen use the gas source for that plasma etchant to remove the organic contamination from the surface, like that oil or some footprint or some that whatever that we cannot remove through that chemicals. So further cleaning substrate. So often the normal sequence of the processing steps involves some type of the high temperature process immediately before coating the with photoresist, for example, thermal oxidation. So if the surface substrate is coated immediately after the high temperature step, the dehydration week can be eliminated. So if we have to immediately coat the photoresist on that substrate after the cleaning, we do not need a dehydration week. But if you have cleaned the substrate, some cleaning process that RCA1, that reactive chemical agent from one process or second process, and you have to keep your device in the dry air, in the air open atmosphere. So before that coating of the photoresist, you need a dehydration bake of around 400 degrees Celsius for your device 30 to 60 minutes to remove the contamination of that either from that moisture or other particles. A typical dehydration bake, however, does not completely remove water from the surface of the silica substrate. So include silicon, polysilicon, silicon oxide or silicon nitride surface. Silicon atom bond strongly with the monolayer of water forming cellular group SiOS molecule. So if you think that your completely water molecules will be removed through the dehydration, it is not possible through the dehydration bake, so you have to go for the plasma agent in that case. So in the presence of the oxygen, you have to provide the RF plasma and you have to clean your vapor before the spin coat of the photoresist. So bake temperature in excess of the 300, 600 degrees is excess to remove the final layer of it. Either you have to do the plasma etchant or you have to increase the temperature of the bake around the 600 degrees Celsius, or if you require you can increase the till 800 degrees Celsius. So further the selenide quickly reform when the substrate is cool in the non-dry environment. So since this approach is impractical, the preferred method of removing the selenide is by the chemical means. So chemical, either use the plasma agent or use some chemical to remove that acid. Either you have to heat in the ethanol, methanol or acetone, or you have to sonicate in the isopropyl alcohol in your substrate. Okay. Any questions?
No, sir, it's clear, sir.
This is the same process we do on a hot plate also during the process for 1 minute and under around 110 degree before just putting the photoresist.
For that adhesiveness we have to do that. For 110 degree will be not remove properly your water molecules. It will
Okay.
be removed if you use that during a cleaning process, something acetone, IPA, methanol. It will be removed immediately around 860 degrees Celsius or 110 degrees Celsius.
Okay.
Okay, because that boiling and melting point of that isopropyl alcohol or acetone, methanol, toluene will be very less.
Okay. Okay.
But water will be boiling point is I think that higher than this reactant that.
Okay.
Because if you use the 1 degree Celsius, it will be remove the water molecules, but it will be keep some residue on the surface. If you
Yes.
see in the microscope when you have to clean that vapor and you
Yeah,
have to run with
clearly
the
visible on the wafer after the. Yes, I have seen sometime.
yes, yes. So you think that this will not completely clean.
Yes.
That's why.
Okay.
So again we have to go some basic of the lithography. So I have take that PPT some IT fab some foreign universities. So so it is that you have to see in that diagram that we have to create a 3D type structure that resist, and we use some substrate, and these are the design that we have transferred on the SI substrate. Like that, some circular electrode and some parallel type of strip we have to develop through the resist. So a technology used to create the 3D pattern with a future size ranging from the nanometer to the centimeters. So for that photolithography, we required that like that EBL, that electron beam or X-ray or UV photolithography, that optical photography for creation of the design of the size of the nanometer to micrometer. If we require for that 200 micrometer or 300 micrometer or in the we can use that direct the shadow mask. We do not go the photolithography. So we have make some shadow mask of that either on that design, printed some design on that our copper substrate or some SS substrate or some bronze substrate, and we through laser writing we have cut that the design on that our silica that SS or copper or bronze, and it will be fixed that design. We cannot change that design or parameter of that design, and we keep our devices on that shadow mask, and then we put the our vapor on the thermal evaporation system, and we directly deposit a gold, chrome, or whatever other materials that metal oxide or powder we want to evaporate on through the thermal evaporations. So if we require the size of the device should be in the nanometers or in the micrometer till 5 micrometer or 100 micrometer, 80 micrometer we use the lithography. So like that, Pritam are maybe he aware about the FinPET. FinPET size should be in the 7 nanometer or 10 nanometer or 3 nanometers of the channel length of the FinPET. So they are fabricated the FinPET through the photolithography only or through the EBL, electron beam lithography. Okay.
Yes, sir.
So according to your size of the devices, you choose the technology which you have to use to fabricate your devices. Not every time, because lithography is very costly. In many IITs have not facility of the lithography. They have the optical lithography. Some IIT have the electron beam lithography facility. So if you have to go to the research, you have to think about that equipment also. That what type of equipment you want to use and what facility you have to require. Okay.
Yes, sir.
So these are the steps that this is a substrate vapor. We have to coat with the light sensitive polymer, photoresist. That will be reactive with that light, that either UV, either electron gun, either X-ray, either ultra UV light. So you have to choose that photoresist material. Then we have to expose with the ultralight photoresist. This is the developed pattern. Okay, and then we have to etch the substrate to expose area, and this will be remain, this pattern will be remain only. Okay, so what will be happen, this gray part will be again that we have to after developer this photoresist will remove, and these are the electrode will be removed but it remain here only, gold electrode paired, and see that this size will be should be maybe in the 10 micrometer or 100 micrometer. And this is the on the lift off process that metals. So again these are the metal we have to deposit. So what will happens, these are the PRs. When we have to remove the PRs, these all metals and PR will be removed, and only these two electrode will be here. So it will be happen in case of the negative photoresist, in the negative type. So if your material will be reactive with something that is the photo PR, that PR or photochemical reactive, then you go to the lift off process. So whatever that sensing material will be not reactive with the PR, because PR will be also in the chemical form. So maybe it will be react with your material. So you have to take care of that also in that case. So this is the class of the lithography. So the resist exposure had to be selective on the substrate to define binary structure. So the lithography can then be in the two mode. One is the mask and another in the unmasked. Mask means you have to you have the prefabricated mask. Your design should be on the some mask like that. I think that Pritam have seen. Pritam, have you seen that mask?
Yes, that
What
chrome
will
mask.
they have the glass substrate on, they have deposited some copper. On copper they have write a design like that. On the shadow mask they have already write the design through the lighter or mask
Laser writer,
aligner.
yes.
To the laser and mask aligner they have printed that on the copper. So it will be pasted on that glass substrate, and then they use in the optical lithography. In case
Yes.
of the unmasked, design like that in the EBL electron beam lithography or EBL, they have said that you have to make your design on that some software. You can change your design according to your specification. In case of the mask, that whatever the prefabricated design you have to only use. But in case of unmask, you can change your device your according to your choice, and using electron gun you can transfer that on that substrate. So in unmask, use the ion beam lithography or laser lithography. In case of that mask UV lithography or X lithography or photolithography. Okay. Any questions?
No, sir.
Huh? Can we move?
Yes, sir.
Yes, sir.
So this is the basic concept, that schematic diagram of the photolithography. So you think that you have the substrate, then photoresist. This is the mask, and this is the UV light exposure. So this will be exposed, this pattern, this black pattern. So this will be not exposed. Only the light will be exposed this area. So it will be on the photoresist. This will be developed on that photoresist, means that the pattern will be transferred here, and this photoresist will be remain here. And then this is the development process. And then like that you have the different type of the printing. That contact printing means that that your mask will be contact with your substrate. In the proximity printing, there's some gap will be there. In the projecting printing, you have used some lenses to project your design on some devices. So in the contact printing, you have to fix that. This parallelly you have to bound that in the contact, then it will be transferred. Like that photo, they have printed photo of our devices. Like that, if you wanted gift your some friend at birthday, and you want to give the cup or t-shirt to your friend with some message or some photo, that memory. So what will they have to first printed a photo on some paper, and then they have pasted on that cup or mug, and then we have to develop. Have you seen that process? Anyone have any idea?
No, sir.
You have not gifted any cup or mug, printed cup to your friend or t-shirt? Jabira, Pitum, I think that IITs have the culture of that printed things that.
Yes,
Sir.
Huh?
student do this. Yeah, student, BTech student do this many time in
Yeah,
the
in the
some
department
cultural
also they
events.
have like that IIT Delhi logo, and they have to gifted a cup
Yes,
and
yes,
everything for their guest.
yes,
So they use the same technology that they have to first printed that design on some paper, and then they transfer from chemicals on that cup.
yes,
Same thing we have to use in that case of our devices. We have to transfer the different design. Like someone want like that parallel design, parallel electrode. Some like that they want to that like that circular strip will be there like that. So we have to different. Some will be fabricated like that from that point. Like this should be strong, and then they have to move, and then they have to like this type of design they have to transfer. So some maybe that they have designed the floors structures to transfer that flowers. Like that in the IIT, there some people will be printing IIT name through the photolithography. I think that Pritam will be aware that about that. On silicon wafer,
yes,
they
sir.
have printed IIT, that IIT Delhi or like that logo they have printed on that silicon wafer. So if you go some video through the photolithography, you check that how that people will be printed the name. If you go through the Intel video, Intel will be printed their name on that Intel through the photolithography. So you can transfer any design on your devices. You can fabricate the any type of the devices, double gate, triple source and drain, whatever the requirement you can print it through the photolithography. So this is the in case of the negative photoresist. So in case of the negative photoresist, we remove the exposure area will be removed and unexposed area will be
Strongest.
yeah,
Strongest.
yes. So this is the typically that vapor prime. This is the vapors. We have to do the dehydration here. Then we have to this spin coat the photoresist. So spin coating that thickness of the photoresist that previously I explained that depend upon the speed of that motors duration and type of the solution that either diluted, more diluted, less diluted that. And then we have to do the soft bag because it is in the solvent form, so we have to remove that solvent from that materials and make the some type of the hardness in the materials, that film type of the structure we want required. And then this is the mask and alignment exposure, we have to transfer that alignment. And then we do the post exposure back because whatever that during the UV exposure material will be uh, maybe some cracks or some change the property of the material. So it will be during the etchant, maybe that over etchant or age etchant will be happen. So we do the post back to for proper transfer of the materials. And then we use the developer. So we use some developer solutions. That after that we developer like that. If you use the PMMA as a photoresist, so you use the acetone with the PMMA developer available. When you have to buy the photoresist, you have to also buy the developer through that vendor doing that. And then this is the optical image of the devices. So it will be seen in the microscope only, optical microscope or EpiSam or SAM you have to use. So optical microscope will available in the market, available in the every lab. So if you see that future size of your device, and then you have to go through the EpiSam. So EpiSam is the field image and electron microscopy. So it is very costly equipment. I think IIT Delhi has around 3 to 4 instruments available in every lab. So they use the easily facility, but the newly developed or facility will be not the EpiSam. So you check that your device will be fabricated or not through the optical microscope. Initially check use the optical microscope. Pritam, have you used the EpiSam?
Yeah, recently I have attended one workshop. During that time, I have tested some samples.
So have you hand experience?
Yeah,
So
little
how
bit,
much?
matlab not much, but we have tested some bio samples.
Okay,
They have
you
same
test the
same and
virus and bacteria you have.
sorry.
You have checked the bacteria and virus that in the bag.
Yeah, some they have some what we call the tissues.
Okay,
The
tissue.
yes, the animal tissues and the plant tissues.
Okay, okay, okay. So, how do we prepare the substrate? That cleaning that. So, cleaning, remove any contamination like greases or organic dirt on the vapor prior to resist coating, typically using acetone and then isopropyl. Either use that chemical etching or either use the plasma. So, have you experience of the cleaning of vapor, Pritam?
I have experienced only the wet cleaning process. That simple one we use acetone, DI and IPA.
Okay,
Not
okay. So,
that.
you have to get in the IPA and then you have to heat in the acetone or methanol.
Yes.
And then you arrange in the IPA, what DI water.
Yeah. Sometime piranha also if needed.
Yes, yes, that HF diluted.
The H2SO4 and the H2O2.
Yes, yes, diluted solution.
Yeah.
Yes, yes. And then you the dehydration. So remove that and then the padding addition promoter that to make the addition of that photoresist use the priming that. HDMS hexamethyl diselenide is typically used for before spin resist. It reacts with the oxide surface by replacing OH group and vapor surface minus CH2. It's leaving free bond to react with the photoresist and to improve the addition. So whatever that OS molecules or any particles, that water particle, selenide hexyl particle will be removed on the surface. We use the HDFS hexamethyl diselenide on that vapor. So you can, this is the chemicals, reactions or HDMS. I am not good in the chemistry and everything. So maybe I skip that things. If you need, then I will be maybe read and then I will explain the next class if you need that. These are just a bonding form that how chemical reaction with the OH and that silicon and everything. So this is the resist component. This is the diagram of that spin coater, and this is the photoresist you have to broadcast on the silicon wafers. So solvent, resin, and sanitizer and additive. So I have included this doubt again that asked by that Jabira. So can you
Yes,
read
sir.
and then if you have, then I will explain again that.
So I have asked like with what material the resin is made up of, sir?
What material?
The resin is made up of. Is it
Resin?
nanoparticles or
No, no, no. You said a mix of the polymer or binder,
yes,
like
sir.
that, like that. When you have to do paint, have you seen the paint?
Yes, sir. Yes, sir.
When in your home, when the painter will be come to paint your walls and everything, they have add something on that paint.
Yes, sir.
What they have add?
Like thinner.
Thinner is for that easily that make the solution that thinner. They add what I said that for sticking your the pen to walls that
Primer.
primers and other thing or the name is that
They are just colors, no, sir.
no the colors to change that we have used the like that we use the Fevi stick and what we have used Fevicol.
Like glues.
Yeah, they use the Fevicol. They add some Fevicol in the pen for
So
addition.
we didn't see that, sir.
Now that whatever that like that if you use the um, white cement, pure white cement. Have you used that for putty for pure white cement? You have used. You have to dilute in the water, and then you have to paint
Yes, sir. Yes, sir. White putty.
like that. In the village, if you have visited the villages wall will be like that. Uh,
It's like a overcoating material, no, sir.
they use the white cement to put their wall that painting. I think Pritam have experienced that. Pritam, from where you are you?
In Rajasthan,
Rajasthan where?
Jhunjhunu district.
झुंझुनू. सो
Yes.
थिंक दैट जो घरों की जो दीवारें बनाते हैं मिट्टी से लोग बाहर,
Hmm.
फिर मिट्टी के ऊपर वो देखो वो डिजाइन बनाते हैं पेंट करते हैं, ये चूना होता है जो वाइट वाइट सीमेंट जो
Hmm.
चूने को लगाने के लिए उसमें क्या वो थोड़ा सा फेविकोल मिलाते हैं लोग ताकि उसका
हाँ हाँ,
एडिशन रहता है उसको.
वो पीडीलाइट समथिंग कुछ बोलते हैं. पीडीलाइट और
हाँ.
फेविकोल दैट्स द काइंड ऑफ.
यस. So that is the region only to mix to for the addition is the region is we have to choose the region according to that photoresist materials.
To
Like
increase
that
the
if you
adhesion only.
yes, for like that if you select the PMMA material, PMMA photoresist or SU8 type photoresist or different type that polymers type of the photoresist. So you have to add some resin to mix some resin that chemicals make them adhesive or make them solvent soluble. Okay.
Okay, sir.
Like Jabira, you have to cook the food. Have you cooked the food?
Yes, sir. Yes, sir. Yes, sir. I do cook.
Yeah.
Sir, you are inaudible, sir.
1 minute, 1 minute. I net. I am audible. Hello,
Yes, sir.
hello.
Yes, sir.
I am audible.
Yes, yes.
Yes, sir, you are audible.
So, have you any experience of the cooking? Anyone?
Yes, sir. Sudarshan cooks well, sir.
You have not cooked.
No, sir, I only do basic cooking.
No. Have you seen that in the kitchen that how the we have to make the vegetables or halwa that sweet?
Yes,
Why
sir.
are people adding the ghee and waters and then sugars
Milk,
to make
sugar,
that to
syrups.
make the recipe? Hmm?
Yes, sir. In the consistency of.
Same things we have to
Water.
make the photoresist. Same things. Photoresist is just like that PMMA. PMA is a polymethylene is just a powder form or polymer form. Okay, so it will be in the solid form. Now we want to make it in the liquid form, so it will be easily drop cast and it easily be uniformly circulate on whole the vapor size. Like that, if you take the 2-inch vapors and you have to drop cast 3 to 4 drop of the photoresist and then you have to spin coat, maybe it will be not uniformly circulate on the whole vapor and if you use the pure like that PMMA, maybe it will be after that drop cast it will be made the powder form and it will be easily evaporate or easily remove through the vapor. Okay, so that's why you use the some solvent, so that will be give some flow to form the soluble. Use some resin means adhesiveness, for that use the some chemicals, so make it be adhesiveness to on the surface of the silicon glass or sapphire substrate. Then use the sanitizer that will be reactive with that photo that UV light or that source electron gun. So your material should be use some chemical, so they have the some optical property, so they can react with the light and it will be help to the transfer pattern. Okay,
Okay, sir.
any doubt? If you have doubt, you can ask me. I think that you have doubt. Pritam,
No, sir. No, sir.
have you used the photoresist in the lab?
Yes, sir. S1813, I think.
SU1813, that is a positive type.
Yeah.
Yes, yes. So you think that it will become in in a small bottle?
Yes, sir. It's in a
Oh,
chemical bottle.
yes, yes. And you have to keep in the freeze also to make it solid.
Usable, yeah. Yeah,
Or
solid, solid.
in the case of the photoresist, your photoresist should be not exposed in the visible or that sunlight. It should be
Yes.
removed in the yellow light or dark room.
Yes, yes.
Otherwise, its life will be dead.
Yes,
It
sir.
is not reactive.
Mm-hmm.
Okay, Zabira,
Yes.
Sir.
have you understand?
Yes, sir.
So it's depend upon the photoresist that what type of the photoresist you have used and how they are the made that.
Yes, sir.
So this is the resist spin coating process. So this is the schematic of that spin coater. So this is the suck where this is the vacuum pump line. So you have to hold your vapor on that suck and it will be hold by through the vacuum. If you, if you not hold that vapor, then it will be when you have to rotate, it will be moved from that suck. It will break your vapor because its speed is around 4000 rpm that rotate that 4000 circle in the 1 minute, so it will be high speed rotation. So if so you use the you have to hold your vapor through the vacuum and then you have to drop cut your resist here. So see that flow of the resist, how that will be, your uniformity will come. This diagram that. You have to drop cast, then is allowed to speed across, then you have to move and it will be uniform here. And this is the RPM speed and different the thickness, that graph. Resist thickness versus RPM speed. So if you keep the speed of that spin coater low, your thickness will be high. Okay, this is the type of the photoresist, that S1818, S1813, S1 that SU8 photoresist type. So if you increase the RPM of your speed, then your thickness will be very less in that case. So you have to optimize that RPM and duration, that how much time you have to rotate that. So it is facility in the spin coaters. You can set your program and then you can rotate. So this is the resist baking process. So a pre-exposure bake or soft bake is used to remove the solvent from the resist. Whatever the solvent we have used to soluble for that resist, we have to remove that. That's why we use the soft bake. So a typical bake is 1 minute on 90 degrees Celsius on hot plate, or 30 minutes in a 90 degrees Celsius convection oven. Thicker resist may benefit from a longer bake time. So if you have the thickness of the more, you have to keep the resist for more time for the soft bake. A post-exposure bake or a PAB is used to reduce standing wave in the regular positive resist exposed on the stiffer, or to categorically enhance the photoreaction in a chemically amplified resist, or also to thermally activate chemical process such as the image resistor. It will also affect the resist profile. So what will be happen when you have to rotate, it will be generated maybe the standing wave type, because it will be circulate. So maybe some waveform, standing wave types waveform will be happen in the photoresist. So to remove that, you have to do the post exposure bake also, that in that case. And this is the example. If you not doing the post exposure bake, your device will be like that, and after that it will be that. So it will be proper, that alignment of the photoresist will be there, and it will be not that boundary will be not happen in that case. Granule will be there. You have not seen the proper boundary or anything, or proper finishing of that. So this is the alignment and exposure. So this is the mark on the substrate we have used to align the. So what will happen when we have to take that vapor, like that we have to put, first we have to align the mark, like that. This is the mark we have to align, and in between that mark we have to expose our device. So during the photolithography, we have first align the things, that these things will be come in this two mark. Okay. And then otherwise, if you have not the mark on your substrate, your design will be maybe half design will be on that whole pattern will be exposed here on substrate, and half will be on outside. And when you have to develop and check in the microscope, you see that your design will be not on the mask, on the substrate. So you have to align first that things. So you have to facility of aligner in your photolithography. You have aligner, you have to put your aligner on that your substrate, and then you have to put your design. So this is the inspect, how you inspect your design. So alignment, first you check that alignment of the pattern, that alignment, and then in between you see that your design. So size of the alignment is very high. This aligner size will be, plus size will be in the, maybe in the size, but this may be in the nanometer, that actual design. So first you check that when you have to put your microscope, you check that this aligner will be there, and then in between you have to easily verify that your design will be where is that. And this type of design you have to see. These are design someone have transfer on that silicon substrate. See that how design will be transferred. Okay. Now, what type of the photoresist? So negative and photoresist, I have already maybe in my week 5 or week 6 explained that. Again, I have to take. So negative photoresist give a feature opposite to the mask metal patterns. That positive and negative is different. So maybe that you use the microgain 747 or SU8 is the negative type example of the negative type photoresist. So photoactive agent on exposure to light react with the polysoprene polymer rubber to form cross-link between rubber molecules, making the rubber less soluble in the organic rubber where unexposed residues. So this is the rubber like the polymers. So that photoresist will be connected with the bond will be a cross-link. That bond will be there. When light will be exposed, it will break that cross-link bond, and it will be transfer the pattern on there on UV light. And whatever the unexposed area, it will be remain some cross-link type structure. So positive photoresist give you the exact features of the mask use. So whatever the exact size will be there, it will be you have to achieve in case of the if you use the positive photoresist. In a positive resist, there will be a resin and photoactive compound. So some type of the resin that adhesiveness and chemical we use may be removed in the case of the positive photoresist. So when you use the exposed light, the reagents must be soluble in the aqueous solutions. So whatever the developer we have used, it will be must be soluble. And the example like that MP240, SPR206, 18B and S1818 will be that type of the example of the positive photoresist. So you can use any one of positive photoresist to expose your devices, to make your devices transistor or anything that diode. So these are the materials we have used that you have to ask Zabira. So in case of the negative, that polymer, that polyisoprene we have used in the SU8, and in case of the we have Novolac resin we have used. So reaction we have the polymerization and photostabilization. What are the sanitizer we have used? Polymer close tightly, change film of the base solution, and for additiveness we use the dyes. So dyes is the another polymers. We have the using that for resin that additiveness for we use the for dyes for both in case of the positive and photoresist negative. So hydrocarbon based material which when exposed to light go under chemical change. So we have the this type H and C type of the bonding in the case of the our positive photoresist in that case. So material restructure itself into new stable form after chemical bond are broken in the bond. So whatever the material we use the positive when we have to expose or something happen we have to treat that photoresist, it will be restructure itself. It will be broken and make the bond itself automatically. In case of the positive PR become more soluble in a developer on exposed to light, while negative PR is a less soluble in a developer. So whenever so it will be react in the opposite direction. Will be work in the opposite direction. Sorry. So mostly high viscosity liquid spin on the vapor 8,000 rpm or higher. So viscosity means what do you meaning by the viscosity of materials? Can
Sir,
anyone tell?
the
Yeah.
flow rate, the fluid flow rate.
So flow rate should be it's like the viscosity of waters and oil. Which have the more viscous?
Oil
Oil,
is
sir.
more viscous
Yeah.
than water.
So that's why we have need the high viscosity. Means it will be not easily when we have to drop something. It will be make it drop only. It
Yes,
will
sir,
not.
it's also known as fluid
Yeah.
resistivity, sir.
This tends to flow rate or something.
It's a fluid's resistivity, no, sir.
What can you pattern again?
So it is a resistance to flow, sir.
Yes.
Viscosity.
Yes. So you need a drop. If it is not viscous, when you have to drop, it will be spread without that rotate of the motor RPM. Okay. So you need a proper drop. It will be drop on the center, and then after rotating through the spin coater, it will be uniformly circulate. So you need the external force to circulate that resist. So it should be highly viscous. Otherwise, without that rotation, it will be maybe some pellets it will be move more and falls like that. Water will be when it will become some direction. Water some pellets will be water will be more or less like that. Okay. So pre-bake, expose, develop, and post-bake next process we have to require. So sensitivity, this is the property of that photoresist. So we have the energy required to expose the resist around 1000 millijoule per centimeter for G and I line. This is the type of the photoresist, and 10 to G and I line is the photolithography that machine equipment. And in case of the, we require a 10 to 20 millijoule per centimeter for in case of the we use the deep UV light. Okay, so whatever the that how much time you want to expose, you to calculate the type of the photoresist, what type of the photoresist you have to use, and what type of source of lithography you use. So very sensitive resist leads to unstable process. So if your photoresist will be sensitive to temperatures, humidity, exposure dose, variations should be specified as a recipe parameters. So you have to when you have to buy any photoresist, the vendor should be specify everything that how much it will be temperature dependent your photoresist, how it will be react with the humidity the present in the atmospheres, how much the exposure dose you have to require, if your thickness will be 10 nanometer or 100 nanometer or 10 micrometer, 100 micrometer, how much exposure dose you have to require of your energy. So higher sensitivity at a particular wavelength is useful. So your photoresist should be particularly reactive only one wavelength. If it will be reactive with the broad spectrum like that, your material will be reactive in visible light also, infrared also, and UV light. Then how you identify that which from how you expose your devices. If you have to put your material on the like that in case simple atmosphere, and if it will be reactive with the visible light, it will be visible and it will be react, and your device will not make your developer, your photoresist will be already exposed, and you cannot again expose your vapor will be, it will be, you are not to expose any device on that in that case. So this is the prime component of the positive photoresist.
Sir,
Yes.
I have a doubt in week 8, sir. Week 8 assignment.
What?
Sir, I have a doubt in the question of week 8, sir. Week 8 assignment.
Yes, yes, tell me.
Sir, it is statement true or false. In VOC or gas sensor, we prefer sensing layer
Week,
made of
week 8.
8, yes, sir.
Uh,
Week 9,
just
sir.
tell me.
Week 9. I'm sorry.
Week
9. Yes,
9.
sir. Week 9, it is an 8th question.
1 minute. Give me 1 minute. I will open. Uh, which of the which is hold for lift of process?
No, sir, no, sir. It is an 8th question.
It is 8 questions.
Yes, sir.
Evaluate whether the below statement is true or false. In
Sir,
VOC
yes.
or gas sensor, we prepare the sensing layer made of the nanostructure material because they have the high sensitivity at low room temperature due to the low surface to volume ratio compared to thin film. Yes.
So, can you justify the answer, sir? Actually, we have put it as false, and it came as a accepted answer, but we are not sure about this, sir.
What will happen then? For that sensing, 1 minute. In case of the sensors, like that we have, this is the vapor of silicon. Okay. Suppose you have to deposit some thin layer here. it is have uniformity. So like that, you have to zinc oxide. You have to take in the materials. Okay. Your sensors performance like that response will be depend if your surface to volume ratio will be high. It should be high, then your response should be higher. So how you calculate surface to volume ratio? How you calculate the surface to volume ratio?
A by V, no, sir.
Yeah?
Area by volume.
Yes. So in case of the thin film, it will be more.
It has less surface to area volume.
In case of the nano structure, like nanoparticle size is like that, dot size. Okay. Or some like flex like structure will be there. Some flowers like structure you have to deposit through CVD or MOCVD or nano rods or some 1D structure or 0D structure like quantum dots. It's like the dots. So dots have the more surface to volume ratio than the thin film.
Okay, sir.
Okay. So that's why this is the false, because in case of the material made of the nanostructure material have high to surface volume ratio, so it have given the sensing at the room temperature compared to the thin film. If you say that lower higher surface to volume ratio compared to thin film, it will be true. But it said the lower surface to volume ratio. Nanostructure or 1D or 2D structure have the higher surface volume ratio than the thin film. Okay.
Okay, sir.
So when you, if you have read the some literature or you have to do literature on some research articles, you have to compare that thin film materials like the Jadeno thin film or Jadeno nanorods. You see that Jadeno nanorods have the higher response in gas than the thin film because they have the more active site or surface site on that surface. Because the volume of that particles will be more in that case than a thin film. Okay,
Okay, sir.
that's why. Maybe I will show you next time. I will show some papers that I have. Whatever I have, I will explain my paper also. That
Okay, sir. So
okay.
that the difference between the peak energy of photon and average energy of photon, sir.
What you say? Peak
Peak energy and average energy of photons.
like that when like that like this is the photon. Okay, when you like that, have you seen that KLM and a layer type structure that
Yes,
bond
orbitals.
orbitals? Okay,
Yes.
so like that, some energy like light will be false, and this type of the light like that this Gaussian pulse will be have to receive somewhere. Okay, what will happen? This is your peak energy, that maximum intensity where we have to receive, and when you have to take average or under the when you calculate the area under the curve, you get the average energy. Okay. When you calculate the area under the curve, how much the energy of take area and take the average of this Gaussian area under the curve, you take the average energy of your particles. Peak energy means where you have the intensity of the peak is will be maximum. Where it will be more crystalline, your particles have the excitation more in it. What type of the what energy like that? So if you like that, it like a 1 milli electron volt, 2 milli electron volt energy, 3 milli electron volt, 4 milli electron volt, and you have to excite it with the change of the energy. Any doubt? Hello?
Sir?
Have you clear or not?
No, sir. I couldn't get you, sir. Actually, it's also from assignment question only.
Week 8, week 9.
Week 8, sir.
Ah,
Week 8, sir.
week 8 or week 9?
Week 8, sir.
Week 8. 1 minute. Which number questions?
Second question.
Chemically amplified photoresist are used with the deep UV source because the peak energy of the photon in the deep UV range is lower than the optical range. Chemically amplified photoresist require less exposure time. The average energy of the photon in the deep range is lower than the optical range. So, peak power is the highest powered output from the lasers. Like that, this is the highest power we have to go for the output of the laser.
Okay.
Okay, like that, this is the laser source that UV light will become. Okay, this is the my material. It will be exposed here centrally. I have calculate the energy. Okay, some like that, some measurement instrument will be that how much that like that UV visible or FTR will be there, or photolumens will be instrument which use to check the optical property of the materials. Okay, so what will be in case of that like that the PL like PL. Okay, here is the wavelength and here is the intensity of the light. How much the intense? So this type of the peak will become either this type of the peak. Some cases this type of the peak will become. Some cases they will be give the two peak. One here, some other they will give. Two wavelength they have to give. Okay. So this is the highest output intensity I will got. Suppose that it will be give me at the 300 nanometers. Okay. During the one pulse, an average that over the time I have take the average. Well, I have repeated this time this pulse 4 to 5 times, 6 to 7 times I will expose and take the average value of that output power intensity.
Okay, sir.
Okay, like that. Uh, like that, you have to measure the resistance of any device. Okay, so you have to flow the current like that. You have to you have measured today resistance. Again, you have to measure the tomorrow resistance. It will be maybe some more or less. You have to take the calculate the data of the 10 days, and then everyone someone asks you that what is the your average resistance of your device. So you have to calculate. You have to add the 10 days data and divide by that 10 days, and you get that my average resistance will be around that model. Or if you someone asks you that what is the highest resistance of a device, you take the one value that this is my highest. Zabira,
Sir?
have you got point mine?
Yes, sir. Yes, sir.
So what is said that questions when you when chemically amplified photoresist means some chemical will be added in the photoresist to make them optically make for selective light exposure for soluble in the selective light. It will react only the selective light like that they have said a UV light only. So what will the average energy of the photon in the deep range should be lower than the optical range. So they, whatever the optical range of that photoresist, the average optical power should be less in the chemical because it will already amplify they have. That photoresist they have already amplified with some chemical reactions. Now you have to require that less average power. If you given that the average equivalent to average power, maybe it will be more reactive in that case. So it will be prepared that your energy should be less than that average that they have calculated.
Okay, sir.
Okay. Anything else? Pritam, Sudarshan?
No, sir.
No, sir.
Pritham, have you any doubt?
No, sir.
Give me 1 minute, sorry.
So in the same question, we discussing the average and a peak power. The chemically amplified means in simple word, we need lesser energy to perform same task.
Yes, yes. Because it already we have some add the chemical, so it required a less energy to expose.
Okay.
Much average. We have to calculate that we have like that we have calculated through some mechanism that to expose that photoresist we require around suppose that 20 millijoule per centimeter square energy. Okay.
So,
Now what we have to require that maybe it will be if we apply the 20 millijoule of centimeter square energy, maybe after if it will be keep on some more duration of time like that we have to keep for the 5 to 10 minutes, it will be maybe damaged at our photoresist.
mm,
Okay, so what will be happen that either the source will be not available with the 20 millijoule of energy or it will be harmful and require more power. So what will be happen that people will be add some chemical, so it will be reduce that energy of
yes.
exposure
Okay.
in the photoresist.
Average energy required is lower than the
they
actual.
they advise that you have to use the less energy as the average energy. So what are the vendor that provide that photoresist, they will provide all the data that average energy required to expose the UV light is around that amount you have to require.
Yes. Okay.
So you have to go through the sheet of that specification of that photoresist, and then you have to decide that what type of the energy I have to set. Okay.
Okay.
Anything else?
No, sir.
So I think I will to remove. So you have to see. uh, So primary component of photosynthesis is non-photosensitive base phenolic resin, usually Novolog. This is structure of the Novolog. We have used the for positive photoresist. Okay. So this is the chemical that organic structure of that materials, bonding of that materials, and then we use the coating solvent like N-butyl acetate, xylene, 2-ethoxyethyl acetate for coating solvent. For solvent we have these materials. Toxic carcinogenic TLV. This is a toxic material which one could be exposed 5 ppm. Now remove from the most positive photos. We have removed these are not we have used. We use now these are because these are toxic for human being and everything, or it will be maybe result for that cancer for that. So if you directly exposed to the photoresist, you have the lot of the disease. If you continuously expose the photoresist, so during the handling of the photoresist, you have to take care of yourself also. You have properly wear the face mask. You have to wear the apron. You have to wear the handwear. You have to wear the gloves and everything. You will be work on the yellow light, so it will be not exposed. You have to use some mask. It will not go to the directly to your breath. Otherwise, you have to problem of the cancers. Infertility will be in the women's or men's will be there. It will be result in the infertility if you continually expose in the photoresist. So this is the secondary component, antioxidant to make that antioxidant when it will be come in the atmosphere, it will not form the oxide. Radical scavengers, amines to absorb O2 and cations, wetting agent, dye to alter the absorption characteristic, addition promoter, and coating aids. So these are secondary component we use the photoresist. So this is the uh, wavelength and energy we have to require. So if you use the wavelength of the UVA region around 315 to 400 nanometer, that energy that required to exposure around that 3.10 to 3.9 electron volt. So you can check that how the energy will be changed with that light, that extra UV and that near ultraviolet and mid ultraviolet. So this is the sheet of that optical source light used for the exposure of that photoresist. So generally this is the G and I line is the positive photoresist. So G line and I line photoresist are very popular for integrated circuit and MEMS. So when you have to design some cantilever or actuator or then you have to use the G and I line of type of the photoresist. So the base material you have the phenolic resin, Novlec. It is a hydrophilic because of the OH group. Means it will be react with the moisture also because it will have the presence of the OH group on the outer side. So when it will be present with the moisture, it will be react and form some water molecules on the surface. Will be you have to find if you have, keep in the open atmosphere. So this is the polydisperse of that materials. You have to see that G line should be exposed 436 and I line should be 365 nanometers. So this is very deep portions. Maybe you have to read when you have to take the admission in the higher study in the PhD and everything that you have to go through that also. These are properties. Uh, this is the another that polymethyl methyl acrylate or PMMA type positive photoresist. So this is soluble through change in under deep UV illuminations. So in the EVL we use the PMMA type the photoresist. I think that's some missing in the PPT. What will happen? Mm, 1 minute. Maybe double meaning will be there. So this is should be the maximum sensitivity of the PMA lies to 220 nanometer. Above 240 will become insensitive. Means your material should be sensitive to 220 nanometer and above 240 nanometer it will be not sensitive to any light. So you have to use the UV source which have the wavelength of the 220 nanometers. And PMMA regions are itself constitute a rather insensitive or slow DPV photoresist require dose of greater than 250 millijoule per centimeter. Exposure time of 10 minutes were required with the earlier DPUV PMA available. If you use the dose of the 250 millijoule per centimeter, you have to keep the light on should be 10 meter. Exposure time should be 10 minutes. And this is by adding a photosanitizer such as tributyl benzene acid, the UV spectrum absorbed by PM increase and 150 centigrade can be obtained. So you use the photosanitizer that chemically amplify with the tributyl benzenic acid, and it will be reduce the UV exposure absorb and also reduce that see that average energy should be 150 millijoule per centimeter square. So this should be we have to use that chemical amplifier that things. And PMA can be used in the electron beam, ion beam, and X-ray photolithography. So this is the again that what will be happen this PPT. So problem with the conventional that deep resist the negative resist on exposed to shorter wavelength. For wavelength less than 369, I line resist strongly absorb the incident photon. And examples like that KR, like this is the KRF2. Here is the KRF2. Uh, to 48 nanometer line are used for 0.8 micrometer to 0.18 micrometer nanotechnology. So like that, this is a KrF2 is also type of the photoresist, and we use the 248 nanometer of the wavelength of the lamp. And if we want to fabricate or transfer the technology of the size of that 0.2 micrometer, 0.8 nanometer, we use this light, and this of the photoresist we have to use. So these are the resist sensitivity in chemical amplification. What of the resistance we use? That intensity of the Hg source, Hg means halogen source. In deep UV spectra is much lower that for G and I line, that thus is not suitable. So we use the standard DNK resist as a 30% efficiency. We use the Alzheimer source 8248 nanometer work, and then we use the CA resist incoming photon react with the photo-Ig generator molecules, creating an acid molecules. These acid molecules act as a catalyst during the resist break to change resist property in the expose. So we use the chemical amplification, that CA full form is the chemical amplification resist. So that will be change the property of the red photoresist. I think it will be boring to you. Yes, Zabira? Any comment?
No, sir, not like boring, but it's kind
It's,
of like
It is
advanced.
lots of theory, I think that.
Yeah,
it's informative, sir.
Yeah, but informative. But what will happen with my slide? I don't.
yeah, there is overlapping.
Font is changed maybe.
Yes, yes. Mm, this is all the developers. So, yes, I will explain again that in the next slide. That slide I have to correct it, and then I think that. So this is the how to we calculate the resist thickness through this formula. So K is the spinner constant, typically range it 80 to 100. You can keep. P is the resist solid content in percent directly related to the viscosity of the materials, and this is the rotational speed in the RPM. Okay. Through that you can calculate the thickness of that material. Through theoretical you can calculate how much thickness we will be achieve. This formula. So this is the how the spin coating will be the work, that you have the spin coat, vacuum, spirit, and then you have to spin that at high RPM. And this is the how that slow coat has spin down and level out, and this is the graph that. So stage of resist coating equilibrium stage, that how that stop. There is a 2 revolution, 30 revolution, and 1,000 revolution. That how this on the corner side this will be formed, some destruction will be formed. That so this is the equilibrium stage. You have gone uniformity of their photoresist. So you have to take care during the coating of photoresist of these things. That so this is the typically resist process. Surface cleaning, we have to clean that. Then we have to use the HMD's applications for that OH molecules. Then we have to apply the resist. We have to pre-bake, means soft baking. We have to align. Then we have to do the post baking. Then we have to develop, and then we again do the handling to remove the water molecules and other residue available on that surface. So I think this slide what. So this is the exposure of that light in that oxygen plasma treatment is coming. So a mild oxygen plasma treatment, so called, is coming remove unwanted resist left behind after development. So in the next or last class I have explained about that oxygen plasma agent. Have you remembered that things?
Yes, sir. Yes, sir.
Sudarshan or Zubira?
Yes, sir. Oxygen plasma.
So whatever that after development developers of that designs on that our substrate, some photoresist will be maybe remain, some residue will be remain on surface. So we use the de-skimming in the oxygen plasma and remove that resist behind after the developers. So negative and lesser degree positive resist leave a thin polymer film at the resist substrate interface. The problem is more serious in the small case when the thickness of that photoresist should be less than 1 micrometer, where the mass transfer of the weight developer is very poor. In that case, we use the oxygen plasma. Pattern resist area are also thin in the de-skimming process, but this is usually for little consequence. So whatever the side effect of in that case of the oxygen plasma will be very less, so we can use in that case. So again, this is the how the reaction with the positive and this is the comparison of that positive and photo reaction. So addition to the silicon, so positive resist is the here means it's not good addition to silicon, but negative is excellent. A contrast means the uniformity or additionness of in that case is means uh, uniformity and strength should be less higher in case of positive photoresist and in case of negative lower. Developer means aqueous based solutions. We use some solvent and mix with some make the buffer solutions to remove that positive photoresist. But in case of the negative, we use the some organ solvent which will be biodegradable and eco-friendly for the atmosphere also. Developer process window means small to develop any device it required in the second time in the nanosecond or millisecond or in the 10 second or 20 second we can develop our device, but in case of the negative photoresist it required around 10 to 5 minutes to develop the device. Lift off process we can use, but in case of negative photoresist it will be easily minimum feature size 0.5 micrometer and below. If you want to develop the device which have size of 0.5 micrometers or in the nanometer you can use positive photoresist, and in case of the 2 micrometer or above you can use the negative photoresist. Plasma H resistant, that oxygen plasma it is very good. So you can, if any positive photoresist will be remain after developer, you can remove positive through the plasma H, but negative you cannot remove through that through that. Step coverage means that whatever the step that if you are make some step it will be better, it will cover very good in but it will be in case of negative resist you have to not get the right. So this is the source of radiations, that whatever the source we have used to expose the optical light. So light optical lithography or photolithography, so we use the wavelength of 0.30 micrometer. In case of the electron beam lithography we use the less than 0.1 micrometer. In case of the X-ray lithography we should use the same wavelength of the light. So this is the E-beam electron beam lithography process. So spot size, that size of your gun should be less than 100 angstrom. So the bottom of this is the spot size where the gun will be false and transfer the pattern. So it will be transferred in even that 100 angstrom of the size can be can be right through that electron beam lithography. So this is the particle size and energy and photons calculations. This is the detector and how that equipment that, and this is the electron guns detectors and transfer the patterns will image will be take place, that is the diagram. This will not useful for you now case. These are back scattered electrons will be majority of the beam electron. Some back drive second electron will be back scattered during the electron beam lithography, and that energy will be not required for useful that in that case also. So when your deck is cut electron, how the profile will be changed, or that pattern profile will be changed, that effect that you can see that. This is the X-ray that you have to use other electrons and everything to the transfer. Uh, this is the X-ray lithography. This is the comparison of that different photolithography, that visible photon, E-beam that you have to transfer the electrons. X-ray means the proper that light, and then ion beam, some ion will be bombarding on that photoresist and the design will be transferred. So this is the high resolution that same images of that devices you have to fabricate it through that lithography, X-ray lithography. And we have a safe memory alloy, again that topic that we have to fabricated actuator. So actuator is the mechanical devices, MEMS devices. So alloy is the some metals. So when it will be, when cooling and heating or something, it will be form structure, it will be, so it will become in the original shape after some times. So actuator like that mechanical some tips. So it will be rotate on somewhere. So as per the surface where we have to perform, it will be fluctuate on that surface. So it have the some flexibility. So where you have to use some cooling environment or heating environment, your device should be work in the case of actuator. So you have to choose that alloy or materials which have the deformation or heating or cooling properties of that materials. So you can use as a actuator that materials. So how they work, when this is the solid form, this is the liquid form, and this is the gaseous form. So it will be happen with the temperature in the form of liquid or gas, that how. So when the most common base phase changes, so small molecules alloy shape change based on the solid phase to transformations. So it is the applications of your devices, you can check the materials. So these are the main type of the alloy used, the coppers or you are the nickel as a SMA. So this is the application of the SMA in the aircraft to reduce the engine noise. Some designer install a chevicrons onto the engine to mix the flow of the exhaust gases and reduce the engine noise. In the automotive heating, that you can use that of that SMA alloy materials. In case of the robotics, in the hand fingerprint, if the people are disabled through the hand, you make that robotics type of a hand and you could put the some alloy. So your hand will, some materials that SMA alloy will be used to move that hands. So these are the made of that alloy materials through that technology, MEMS technology or extruded, and use the civil structure and grounding some SM rod that is flexible in the temperatures and in cooling. It will no effect, either it will be form, it will change their property according to atmospheres. Okay, this is from my side. Any questions? Anything you want, you can suggest. Any doubt till now? I will write, if possible, I will answer now, or I will write and include in the next class.
All okay, sir.
No
Yeah,
doubt, sir.
No doubts.
Sudarshan,
All okay.
No doubt, sir.
No doubt, sir.
I think today is very, that class is very fast, I think, ne?
Sir?
Devina? Today's lots of theory and PPT is full with the some
Sir, it's completely, it's entirely,
lots of sentences and words are there. Huh?
But actually, the last
it
PPT is
entirely
little
contains the photoresist, sir.